Okay. Hello, we're back with another discussion. We are group one. This is chapter 35 and 38. So, the first part of this chapter is liquid crystal displays, LCD monitors. There's a lot of positives and really just like one negative. Um, it was lighter, cheaper, and lasted longer. So, one of the negatives was just that it was hard to see. You had to stand right in front of the screen. Um, like if you're trying to show a doctor or something, he would just have to like move you out of the way so you could see. Um, yeah, Zach, did you have a question on this, or did you want to add something
Yeah,
first?
yeah. One comment was on the limited off-angle viewing that you mentioned. That's on table 35-1. I've noticed on some of the monitors that a tech will be like pointing something out to me, but I won't be standing right in front of it. Um, say I don't really see that, and then I move, and then it pops up. Like sometimes when my markers get burnt out on the side,
Yes.
like they can
Hmm.
see it standing. They're like, "Oh, it's right there," and I'm off to the side, and I'm like, "Oh, now I see it." But I never realized what that was or what it had to do with. Um, but I guess it has to do with how it's made. Um, and then one other question I had was on the nature of pixels in display systems. Um, I'm not really understanding like the breakdown of it. I mean, Professor Steele explained it, but it doesn't really, I don't know, I can't see the breakdown of like the individual, like before it was like individual pixel and then the
Yeah.
matrix. So that was easier for me to understand. But this one, and then you throw in like only three colors are emitted together or are emitted and they can be emitted together. It was a little confusing to me.
Yeah.
Yeah.
So in each pixel, the hardware pixel, it breaks down to 18 like segments, but each subpixel is like six segments. So there's three individual subpixels, and each segment could make its own color. I think the colors are red, yellow, green, or blue. So each one of those three will be red, yellow, blue, or yellow, green, or blue. So they're able to make a color in between those, I believe. And yeah, that's what I got from that.
Yeah.
Okay.
From what I'm pretty sure it is, it's kind of basically like if you like paint and you mix colors, if 50% of the red and 50% of the blue are being emitted, then you'll see purple. If all of them are completely lit up, it's white. And if there's no light coming out, they're black. So I think it's like kind of a mix between all of the colors, like how much is being like shown, it'll show a specific color. So there's only three like primary colors that's being shown, but
Mhm.
depending on how much of each or one or two or any or all, it depends on the color it'll show, I believe.
Okay.
Yeah, and then with monochromatic LCD, it's just shades of gray. Each one could do three shades of gray, so it could make a gray image on that pixel. Believe that's what it was.
Okay.
I'm like confused the whole I think he like in the lecture went from like he was talking about like a whole segment makes up a domain, but then the domain makes up a subpixel and then the subpixel is like considered three. I don't know that whole thing like I guess I don't understand and like I don't really get the breakdown of it.
You referring to this picture? I think this is from the book.
Yeah. I don't know why I'm just not getting it.
I think it's confusing because we already have like in our heads a definition of a pixel from elsewhere in our studies. So I think it's hard to separate this out because it's a different thing with a similar name.
Yeah.
So what I'm understanding, I don't know, correct me if I'm wrong. So the subpixel and the word domain can be interchangeable.
I think it's domain and segment because the subpixel is the whole row, I believe.
It's six of them, the subpixel.
Yeah.
Yeah, six segments make up a subpixel.
Okay. So a domain can be interchangeable with a segment.
That's what I'm taking it as. I'm not sure if it's actually interchangeable, but from what I'm seeing, each domain equals one. Like, now I'm
Subpixel.
confused. Now I'm really okay. Yeah. I thought it was segment.
I'm sorry. But I could have sworn he like I remember and I had to repeat that exact same like 5 seconds of the lecture. It was like 10 seconds because he was like breaking it down, but I just wasn't I don't know, I just wasn't understanding. I guess I'm gonna have to repeat that 10 more times
So
to understand it.
I know he had two video links, and I think it was about pixels. So maybe I don't know.
maybe we need to
So
rewatch those.
yeah,
Oh,
so it says so in most, this is on 635. It says in most LCDs, a single hardware pixel actually consists of 18 individual bar-like segments. So a pixel is made up of 18 bar-like segments.
So this whole box right here
Yeah,
Is
that's a pixel.
yeah, the
is
entire
one
thing
hardware
is a
pixel.
is a hardware pixel.
Mhm.
So now they're arranged in groups of three called domains. So each group of three is called a domain, with each pair of domains making up a subpixel. So each pair, so 6 bars
Oh.
is a subpixel.
Yeah.
And then
So
three
wait.
subpixels. So there are three subpixels in a pixel,
hmm
and each subpixel has 6 segments.
Mhm. Yeah, I
so
think
the
it just
segment.
allows it to make a different color, like on the top of the pixel and then on the bottom of a pixel. It allows it to have different colors. So
And
it makes the color.
that's how we get the dynamic range or grayscale.
Mhm.
Okay.
So the subpixel, sorry, last question. The subpixel isn't everything highlighted, like, because in that picture it has three and so a total of six, and
Mhm.
that whole thing is boxed as a one subpixel.
Yeah,
Yeah.
six of
Yeah.
them. Yeah, there's three subpixels in a hardware pixel.
If it was just three of them, like these ones only, that's a terrible circle. Would that be the domain? Is that what it's saying? So each clump
Yeah,
of three
Yes.
is a domain. A pair of domains together is a subpixel.
yeah.
Oh, and the whole, and sorry, and the segment was
Just
everything?
The
That one.
individual.
one singular
Bar.
Got
bar.
it.
Thank you.
Got it. Thank you. Okay, because that picture
So it
confused.
goes segment is the smallest bar. A group of three is a domain. Pair of two domains is a subpixel, and this whole thing of 18 segments is a hardware pixel.
Thanks, guys. I understand it now.
That
Thank
was
you.
actually
Yeah.
really helpful. I struggled. Baby boy.
Did you guys want to go over the pneumatic liquid crystal? It's a bit higher on the chapter 35. If you go up, it's
So
something
what
he says we need to know. It's the on
yeah,
state
what
and the off state.
what I found helpful, like just on a very generic understanding, was like
Mhm.
how he described it as kind of being like a grid.
Yeah,
Like if it runs parallel, then you can see it, and if it runs perpendicular, it gets trapped.
yeah.
So
So
that helped me.
yeah, if you go down to see the image. So a light wave enters through the vertical side, has to be vertical, and then the pneumatic liquid crystal spins them so it could exit through the horizontal side, the light wave. And On an on state, the transparent conductor has no electricity.
Hmm.
That allows the spindles to, the pneumatic crystals to spin. And then on the off state, the electricity is on, so the pneumatic liquid crystals, they don't move, so they just go to the side over there. And I don't think, um, so when the light wave enters vertically, it doesn't exit because it's not being spun to exit horizontally. That's how I,
So
yeah.
so off state would be a voltage is applied
Yeah,
to the
Current,
transparent
yeah.
conductor
yeah,
current.
the transparent conductor, yeah.
Hmm.
And that
Okay.
pushes the pneumatic liquid to the side. Doesn't allow them to spin the light wave.
Okay.
Yeah, and
Uh,
the horizontal is the polarized glass panels.
Okay. The polarizer.
Yeah, polarizer.
Okay. So it's similar to like oh, what did we talk about in Professor Scudellar's class? Like the cross grids.
Yeah, I think
It's like
so.
Oh,
that, right?
yeah.
Like,
It's like that.
that's a
They're
cross
lined
So
up
grid kind
like
of right
that
there on
for
the
right.
off
sure.
state.
So what this is talking about is just changing how the light comes through.
Yeah, so I think on figure 35.2, if you go up on the notes, that's basically the off
Mhm.
state. 35
Oh,
two. There's an image if you go up right here.
Yeah.
That one. That's basically the off state, what it looks like. Because
Okay.
you got vertical panels and horizontal panels, and then it's kind of like a cross grid. So
hmm.
it's really going through. And that's the light wave entering the green.
Okay.
So what I understood from the off and on state is just like the off state electricity is in, and when the electricity in, it makes the crystals all line up in the back, so then it can get through. And then um
But it doesn't exit on the off state.
it doesn't exit.
No, because they just die there because the light waves have to enter vertically. And then this is only like an exit for like horizontal light waves.
Hmm.
So as it enters, it doesn't get spin, and then it just dies there,
Oh yeah, yeah, yeah.
the horizontal. That's why he has like the, oh, you got an X there, a red X.
Sorry.
No,
I
that's
drew all
good.
over the pictures.
It kind of explains it doesn't go out.
Yeah, that was the idea,
Yeah,
as opposed to this one.
yeah, that one goes all the way through.
Yeah, okay.
Any questions on that one?
No, I felt pretty good about that actually. The only thing that was weird was just thinking like when it's on, there's no current, and when it's off,
Mm.
there is current. So like remembering that
Yeah,
that it's inversely proportional to electricity or no electricity. So where I could get caught up. So I just remember that. And I liked
yeah,
his blinds analogy. Pretty simple.
yeah.
Yeah.
So, does anyone have questions on chapter 35?
Think the rest for me was pretty good. It's mostly
Okay.
about the hardware pixel that we went over.
Yeah,
And I think
Yeah.
it's cool that for us it's we just use the monochromatic, so we get 3 times the pixel count, basically, since we only have grays. So it's kind of cool.
Yeah. Yeah. The topic of um, smaller pixel units and increased matrices and how that applies to increased resolution, that comes up a lot in 35 and 38.
Hmm.
yeah, and it talks about like right there that the radiologist has like a really nice way of seeing their images, way better than what we could do or a regular LCD monitor.
Yeah.
So, so go to chapter 38 now. And first thing on chapter 38, where they talk about mobile, like portables. So I believe Natalie and Stephanie haven't had a chance to use portables yet. Um, it does take some time to getting used to it. I think like the chest x-rays are like one of the hardest ones because you
Yeah,
have to
they are. It
match the
shouldn't be,
angles.
but it is.
Yeah, seems like so easy in the rooms, and then you get to the portable and you get humbled.
Yeah.
It's really hard. It
Yeah.
takes a long time to figure it out. You always like miss the angles or the clavicles just really thrown off. But besides that, it's just like being careful with the portable. You always got to plug it in, like how Professor Steele was saying. It dies really quick. Yeah, it's an
For those of you that haven't had portable experience, this is really a helpful slide right here.
yeah.
I would have liked that before I was doing portables. I was like, oh, that's so helpful. So that little picture and telling you where to stand
Mhm.
is a really concise way to put it that would have been helpful for me, when I first started doing them. So that's cool that you guys are going in having that information.
I thought it was
Yeah.
also helpful that he said that like because it's kind of hard to like measure SID unless you have a little tape measure, and him saying that if you're at the end of the bed at a gurney for a chest x-ray, that's like give or take pretty good for 72 inches. So that's kind of good information because I would not know how to eyeball 72 inches.
Yeah, and you do have to kind of back up a bit because when you do on the gurney, you put them upright,
Mhm.
so they get kind of closer to you. So you do got to back up just a bit.
Thank you.
But yeah, it's typically the right spot, the end of the t gurney.
And also, Professor Steele mentioned just like a quick little thing about how you have to sometimes pull the patient up in the bed because
Mm-hmm.
you'll notice like when you go to sit them up,
They're
most
really
most
low.
of the time
They're
their
going to be
bottom is not like in a little indent. They're
like
gonna
right
be,
Right
here.
in front.
closer to the foot of the bed. Yeah,
It's
so
like if
when you
their
put them
bum was
up,
down here.
yeah,
Mhm.
when you put them up, their
They're
chest,
like
they're
this
like,
angle.
Yeah,
yeah,
nice.
and then then you would have to come in like really, really steep, and then your plate's not flat on them.
And a lot of times, like when we're up on the floors with, inpatients that are on chest tubes and whatnot, like that's all, we can't move them. So we're like literally right over them, probably at, I don't know,
Yeah,
20 inches. Like that's just what you can do. There's nothing to be done. So
yeah,
it's awkward.
Yeah, you get your chances of doing supine ones too for trauma views, especially at
Hmm.
VCMC. You'll do a few trauma views of chest supine. Okay. And then leading on to the next, what are we on here? So I think next is the intensifier, the image intensifier.
Yeah, I had questions about that.
Me too.
I think we all did on this one.
Yeah.
What's
Uh,
your question, Stephanie?
well, I'm also confused with the components. I know Lisa had a question for that, but mine's a little more further down. So if Lisa, you want to ask your question.
Well, mine was just, I kind of wanted just to go over this whole process because I kept thinking like, wait, we're back in the X-ray tube. No, we're not. We're like on the other side of the patient, but a lot of the components are pretty similar. Like we've got an accelerating anode, we have a photocathode instead of a cathode. So I kept getting confused um, with what was going on here. And then it was great clarification to finally find out what an II is because at clinical sometimes they say II and sometimes they say IR and I'm like, well, what is the difference? And no one really explained it to me. So this I thought was actually really helpful. I just kind of wanted to go through it if someone felt comfortable with this information.
I mean, yeah. I was having a hard time too, but I don't know, Zach, do you kind of understand this one a bit better?
um, so I have been in fluoro maybe like 4 or 5 times because when I go to St. Inez on Tuesdays and Thursdays, the rad is not there. The rad's only
Mm.
there Monday, Wednesday, Friday. Um, but I think Lisa, you had a maybe up a little bit. Like when it said light to, yeah, the X-ray to light to electron to light.
Oh, that's down. It's like the summary.
Yeah.
Oh
I
gosh.
think I think if you understand that process, um, it's going to
Okay.
be really big because then you can look at it and be like, okay, the incident X-ray beam goes to the input phosphor. So you're going to get light emitted from that, correct?
Mm-hmm. This is what
And
you're talking
then,
about, right?
yeah,
So the radiation, like our X-rays, they hit the input phosphor and they're converted to light in the photocathode.
Gives off light.
It's like
yeah,
invisible light. So it's
yeah,
radiation to invisible light, and then at the end it makes it visible light, which was what we see at the mo in the monitor. Um,
yeah. And then from the input phosphor, it goes to the photocathode. And the photocathode receives the light emitted by the input screen phosphors and use the light energy to free up electrons. So now you have freed up electrons, and then it shows in figure 38-7. Professor Steele said he didn't like the image, but it
Mm,
labels like
yeah,
the electron beam.
I don't think I put that in
Um,
here. It's
and if you look closely,
maybe
I think you did.
I think I did somewhere.
Um,
That's not it, but that's
okay.
this is the
But
same thing.
so in the book, it shows the electron beam starting at the photocathode, not at the input phosphor. So that tells you that there's like a gap.
Oh,
Yeah.
okay. Actually, that's
So
kind of
that so
helpful.
that shows that the input phosphor gives off light, photocathode gives off electrons. And then you have the electrostatic focusing lenses.
Those
So
made sense to
that's
me because they're negatively charged, so they're like pushing the
they have positive voltage.
electrons.
Mm.
Yeah,
Okay.
they're positive, so it kind of pulls them in.
Okay.
Yeah,
Um,
magnification.
and they have, I think one of the big things was that they have
Oh,
increasing
increasing.
degrees. Yeah,
That's why.
yeah, because then you
Okay.
have the output screen, which is much, much, much smaller.
Smaller.
Yeah, so you need to focus, because you have this big electron beam, you need to focus it to, he calls it like the focal point, right?
Focal
Which
length.
is not, yeah,
Or
not really mentioned in the book.
Mm-mm. But
Um,
yeah, it's where it crosses. I know what you're talking about.
yeah, so then you have minification, right? So that is the process of focusing the electrons onto the output phosphor.
And it's
So,
taking the same amount, just putting it on a smaller area, so that's why it has increased brightness.
uh,
yeah,
yes,
Okay.
yes.
because that the input phosphor is bigger in the end, so it's all of these radiation converted to light and then freed up electrons, and then you have to make it into this little area, and that's the process of like minification, making the path
Got
smaller.
it. Got it.
So then the path becomes smaller and it increases the light because it's focusing the large into the small, is what I'm getting.
And
No, that
how
that makes
I
sense.
remember that is Professor Steele said a magnifying glass using sunlight.
Hmm.
So you
Oh,
take
that's right. That's
all the
helpful.
sun's, rays, put a magnifying glass, and then
Light
you
your
have
little
this
leaf on
really
fire.
concentrated beam of light. And that's much brighter. Like it hurts your eyes to look at,
Yeah.
like after the magnifying glass, and you can set leaves or ants on fire, you know?
Hmm.
Um, and then you go to, so after the electron lenses, you have the accelerating anode, which is kind of familiar to us,
Hmm.
um, in the sense of it
Like a
attracts the
target anode.
electrons.
Yeah.
Yeah. Um, and then you accelerate them toward the output screen. Also another small ring of metal. We use tungsten in the X-ray tube. Um, does that make sense up until that point?
Yeah.
Yeah,
Yeah, that does. And then the flex gain is just basically the measurement, like of the ratio of how we did.
Yes.
So in the Clover Learning, I don't know if you guys did that already. You have to do the math. Do you know if we have to?
I
Did you do that already?
no, I haven't.
haven't done it either.
Oh, well, I put some of them on here, I thought, because it was related. I was like, oh my gosh, do I need to know all these things?
I think he said, I could be wrong, but I think that he said in his lecture that we didn't have to do them, that he wasn't going to ask us about that.
Okay, good. Because the Clover Learning does. So I took these out of Clover Learning, and you actually had to do these math in the.
I'll go over it again and just to make sure, but I'm pretty
Yeah,
sure.
he didn't mention any of that in the lecture.
Hmm.
Okay, cool. That was really helpful, you guys, actually. And here's that focal point thing. Oh, someone had
Yes.
a question about that too.
Yeah, I did on that, but kind of bouncing off what you guys were saying with the minification, like the whole magnifying glass, like bigger light to smaller, would that like go hand in hand with the focal point in um the image intensifier? Because if you scroll down um right there, the focal points, is that the same idea or is that completely different?
I think it's connected.
Is that
Yeah,
what?
I think that focal point is what the minification is like focusing on to that point.
So is it like the act of minification is happening at the focal point? Like that's what it is. Like would it be like kind of like and
Mm,
I don't know.
I
I
don't
don't think it's a
think
physical thing.
so. I don't think so. I think the minification is just from the input phosphor with the large field concentrating all to the output phosphor is a small field. And then in the middle of it, we have this um, magnification mode if we
Yeah.
use it,
is
which
that
is
what
on the C arms
uh,
that I
Hmm.
didn't ever understand
that where
before.
like the bottom like flips? So what would be on the bottom is on the top and the top's on the bottom, but then you have to flip it again.
Oh,
So
that's a whole, I think that's somewhere else.
but is that where that happens in the focal? Is that the whole?
No, I don't think this has anything to do with the flipping. This is like by moving where this point constricts, um gosh, it's like it's like that flashlight thing from
Hmm.
Chuck's class. I'm not explaining this well at all. But if you think of the flashlight as that focal spot and you move it farther back or closer, you're going to be magnifying. You get a smaller field of view, but you can see it better. That's a terrible explanation, but Zach could probably better explain that, I have a feeling.
Um, so in the bottom of 38.8, like that diagram, so it explains it. It made sense to me in my brain, but in magnification mode, B, the bottom one, the active field of view at the input phosphor, which is on the left, is reduced in size by pulling the point of the electron beam closer to the input phosphor.
We have 10
So
minutes, FYI.
as you pull the focal point closer, you minimize it at the input, which now magnifies it at the output. Does that make sense?
The
Because you have
magnification
because
of
you have go ahead.
That's right.
sorry, so the magnification of the field of view is controlled by the focal point. It's not like the field of view.
Correct.
Oh,
Yeah, so you pull the focal point. So like say you have 100%, right? And your focal point is at 25%, right? If you move that to 50, now you're going to have 50-50, right? You're going to have more on like the output phosphor side as opposed to if it's, at 98%. You're only going to have 2% that's going to be projected out to the output phosphor. But if you have 25%, that's going to decrease your input phosphor side while simultaneously increasing your output phosphor side.
Okay.
That makes sense?
Yeah, that
Yeah.
makes for sure.
It's like counterintuitive to me.
Yeah, it is.
That's
It doesn't.
I had it flipped, but okay,
Yeah.
helps.
I think I kind of did too.
Also, it says right here, changing the electric charge on the electrostatic lenses brings the focal point of the electron beam closer to the input phosphor. So the electrostatic lenses are already positively charged. Is that just adding more charge to them?
I would think so. Or wait. Yeah, or would it be less? Because positives attract, right? Or opposites attract.
Or making it like,
I think what that is saying is as you increase like the charge of the electron lenses, they're gonna want to come in tighter, closer to the input phosphor.
oh,
So it's gonna be charged. It's gonna want to attract at a I don't know, at a quicker. I'm not explaining it well, but it's just
no, it makes sense.
as it increases in charge, it's going to be closer to the input phosphor. But if there's no charge, then it's going to want to go just in a straight line, even though there's some charge already. Does that
Yeah,
make sense?
yeah, it does. Thank you.
Okay. I think someone had a question about a automatic brightness control. Was that right? Or was that USAC
Um,
or was it the ABS?
Oh, me.
Oh, is that you?
Yeah.
Okay. What was your question
I,
about?
First of all, what does ABS stand for?
Stands for
Automatic brightness, like the S. Because I feel
um,
once I get that, I could put everything together.
stabilizer, stabilizer.
yeah, stands for
Uh,
It has to
automatic
be.
brightness stabilizer. Stabilization.
yeah.
Automatic brightness stabilization. Was that your
Oh,
question on the ABS or was it on the ABC?
now I just, sorry, we have like 6 minutes, but I just, I guess those whole things like confused me about the four different types. And he
Okay.
said only to vary about the one that's basically set, like the set MA and AP.
Yeah,
Yeah,
we
there
go
were
up.
four listed, and then in his review, he brought it down to just two. So I was also like
Oh, in the review.
confused.
Okay. Yeah.
I guess it's just that whole like ABS thing. I feel like there's so many like little components in that thing that it's just confusing, like the circuit types, and then there's like, but the two main ones are the automatic gain control and then the automatic brightness control.
Yeah,
So
and that's how you compensate for part thickness that's
yeah, like
changing in the patient.
ABMA.
Yeah. So there's the AGC and then the ABS. So I think you have to distinguish between those two. So AGC doesn't affect exposure factors. ABS does.
Yeah, with
So that's
ABS, you're changing like the MA and then the KV
yeah.
and stuff like that just to get a good image.
Hmm.
Does that make sense? So like AGC has to do with the monitor. You've already taken the image, you're manipulating it on the monitor screen, whereas automatic brightness control, it automatically adjusts your technique to increase the image quality
Yeah.
before
Okay.
you take the image,
Got it.
which is more common.
Okay.
Oh, there's a typo in your notes.
Where,
It's
where?
automatic brightness stabilization, not control. The
This one?
ABC is supposed to be ABS.
Oh no. Thank
I
you.
think
I'll
there
fix
is an
it.
ABC
Yeah.
one.
Is
I
there?
think there might be.
Yeah.
I think it was ABC.
Yeah, there is an
Sure.
automatic brightness
That
control.
sounded like
So
so
he
That's
just didn't
that one's kind of works similar as like the ABC. It's just
I think it's confusing because the heading says in the book and also the slide says automatic stabilization of brightness, but that is ABS.
Yeah.
So it's just written in a
Yeah.
confusing manner. So
okay.
I will
Yeah.
put that note in there also. But yeah, please tell me if you see typos because I heavily rely on these notes. The objectives was a lot, but I liked that he said just be able to understand seeing them. And he may sneak in some other ones that aren't on that list that wouldn't make sense, and we need to be able to recognize that.
Yeah.
All right, we got a few minutes left. Is there any other questions or stuff you guys are not understanding? You could go over real quick.
I thought the images that he posted of distortion in the lecture slides were very helpful. Because there's no real images in the textbook, but it makes sense like when he posted those and talked about it. I thought that was very helpful if anybody's having trouble on those.
These ones I thought were really good also.
Yeah. Yeah.
Yeah, nice images. Yeah, veil glare, and then yeah. The C-arm, the C-arm stuff. If you guys wanna,
Oh, there's that flipping thing, if that's what you were talking about earlier. I got this from a tech. He says it
yeah,
makes sense. Am still struggling with it every time I go in to the OR, but I think that that's normal. It takes a while to figure it out.
Yeah. I also don't have any OR experience,
yeah,
so
me neither.
it's going to be a fun summer.
Even just with the amount I've had, I still find it very confusing. Unless I'm doing the same. If I'm doing a right anterior hip, I've done that one the most. I could do that. But you change it to anything else, and I'm all turned around. Even if you go to the left side, I'm like, oh wait, this is different. It's totally weird. I
Yeah.
think just practice is all.
Yeah.
When you go
And
down, do you have like road mapping on there?
Oh yeah, I do. That was kind of confusing. These. Is this like an
Yeah,
ERCP? Has anyone done that?
I haven't,
mm-mm.
but it does show you like the vessels and stuff, the road mapping.
Hmm.
Thought that was interesting.
I think this has to do with ERCP, but I am not sure. But I think I've seen something like this. I just didn't understand what's happening.
We also have less than a minute right now, by the way.
Yeah.
Same.
All right.
Yeah.
I guess that's all we have for our discussion today. Thank you guys.
Yeah, thank you everybody for your help.
Thank you.
Thank you.
All right, just stop the recording.
It's gonna